Go.
Okay. Hi, with Robofish project for UCI. With Baldwin Mateo.
I'm Katia Morales.
I'm Christian Neves.
So some of the background for our project, Robofish is usually taken as a class, a one-quarter class, MA 165 Advanced Manufacturing. It's usually, like I said, a one-quarter project, so students tend to build a more simple designs such as fish, which is something similar to what is shown right there. Us, on the other hand, we're taking it as a senior design, so we have decided to take it for 3/4. So we decided to make a more elaborated sea creature, which is going to be a panorama. Some of our personal background are some of the classes shown here. These classes have helped us with some skills and experience that we have incorporated into this project. For example, engineering 7A7B showed us basic manufacturing, the Arduino coding, and then MA52 helped us with SolidWorks, which is what the program we used to create our model for this project, and then MA106 helped us with more electrical circuits and things, which is what we have implemented into this project as well. The main reason we chose Robofish for our senior design is we have already had previous experiences with land and air projects as MA1, 7A and 106, so we wanted to challenge ourselves with a water project. So the main goal for our project is to create a sea creature that is able to move 12 feet underwater while being completely submerged. The objectives complete all of our design and modeling by last quarter, which we have already done. By this quarter, we wanted to finish all of the calculations. And for next quarter is all of the manufacturing, testing, and revisions. For our requirements, like I said, we have to have it move at least 12 feet underwater. We don't have a weight or a size requirement, but we do have to make sure that it's not too heavy where it sinks all the way to the bottom and not too light where it floats and it goes above the surface. And then it also has to mimic the motions of the actual manner.
This is our timeline for this quarter and next quarter. So initially, we had finished all planning and modeling by last quarter, but after talking to our advisor and talking amongst ourselves, we kind of ran into some issues with our previous design. Mainly it being, we were concerned that it might, on its stability and ability to maintain balance. So our previous design was a bit susceptible, we thought, to tipping over, and we weren't sure if we can ensure that it stayed at the orientation we wanted it to. So we went back to redesigning and modeling this quarter. We finishing up the calculations, and then moving forward, we expect to finish manufacturing, to start manufacturing by the end of this quarter. And hopefully the majority of next quarter is manufacturing, testing, and redesigning if necessary. So progress, so as now we finished all planning, we finished all modeling, and we have our parts and everything, so we just kind of need to order and then hopefully begin manufacturing by this quarter. And for the most part, we finished all the buoyancy calculations for our current design. We found that it's about 0.5 kilograms light, so we need to add some sort of weight to it to ensure that we can get it at the ideal, so we can ensure that it doesn't sink or float. So that's our current design. So we have the main body. The current plan is to 3D print and coat it to ensure that it's completely waterproof. We have an O-ring in between its two halves that come together. We have an O-ring and a sealing mechanism or a sealing design inside where they clamp together, and it's waterproof by the O-ring inside. The wings, we plan to cast them out of silicone. So there's an arm mechanism that's going to go through the wings, and they're going to be cast around it. and the servo from the inside actuates it and gives us that the forward motion from this design. So overall, the shape is about, for the main center body, is about 8 inches and then 6 inches width, with each of the wings being about 6 inches long as well. And then this is our flap mechanism, flapping the propulsion mechanism inside. I'll let Christian talk about it.
Alright, so the propulsion mechanism, originally for original design, we were thinking of having like 2 different servos, one at each end. That servo would pretty much hold will be holding the wing, the silicone. But what we didn't want was, so if the wing were to go like up and down, we didn't want the servo to then stop and then have to go pretty much all the way up. So what we want is pretty much, the servo would be installed, would be here in this gear. We just make the servo run continuously 360 degrees while it's on, and then that way it will just continuously be flapping. Also with this design, the way how it's going to move is that we did say that our manta was going to be like, it's a little bit lighter, so it'll probably, it won't sink, it'll probably go more towards the surface. So as it's flapping, there's going to be more force coming this way, coming up, so then that way if it is going up, there's more motion going up so that it can sustain it going down. Because it is, pretty much weight is a big problem like for our design. Alright, and then budget. So the budget, it's given, the requirement is given by a project advisor. Pretty much it's $100 per person, making it a total of $300. While we finalized our part list, it did come out to be $193.10. It's pretty well beneath our budget. It's more than $100. We have 106.90 cents left over, and then we're thinking of ordering the parts soon. Any additional money will probably be used for extra 3D filament. As terms of 3D printing, our TA. Hassan, some of you may know him, but he has his own 3D printer. The only thing he asks of us is pretty much provide our own 3D printer filament. This is a more detailed of what kind of parts, along with pretty much the URLs, where they can be found. We're doing a lot of Reno Nano. We're doing 2 micro servos. The reason why, it's not because from the previous design, one on each side. No, instead, go back to the mechanism. So what we want is to have 2 of these, just so I can create, enough force, because water, it's not like air with pretty water is more resistant than air, so that way we won't have enough power. We want to build 2 of these, therefore 2 servos, control it. Go back to the part list. We do want to have like an external battery. We don't want to connect, our laptop to the Arduino, and also, the simple stuff, tiny breadboard, the XTC 3D, that's what's going to be coated for the wing body to make it more water resistant. And also, we are trying to see, if there is a cheaper option in terms of like silicone for the wings. But as of now, this is what we have. And then resources. This Robofish project, we are a very small team. Really, it's only 3 of us. Oswaldo is the leader, and then we have myself, Christian, and Katia. And then our project advisor is Professor Mark Mardu. But our main point of contact is pretty much like this PhD grad student. His name is Hassan. He's the guy that we pretty much meet up. Whenever we have any questions, we go to him. If we have like any design questions, or like if we want him to evaluate our designs, we go to him, and he tells us, he kind of gives us little hints of pretty much like what is better. But obviously it's up to us to research, what is more feasible for us. Like for example, he did mention, probably do carbon fiber for the body. But carbon fiber is like a more complicated process. 3D printing, that is something that we are going to take into account. But first, we're going to try to 3D print, run different tests, see if it works or not. And then sub teams, like I said before, very small team. It's only 3 of us. Oswaldo is pretty much the main body structure. I'm more in charge of the motion mechanism, making sure that the manta does propel forward. Katia is more in charge of electronics. You know, I'm working with the Arduino, working with the servos. You know, but at the same time, we're not bounded by these roles. Again, small team. We kind of like piggyback on each other. You know, help each other out. If we have any questions, you know, something we just come to each other. And
That's it. Thank you.
yeah, presentation.